I think I f***ed up somewhere. Oh, look, it's working. These numbers seem a bit weird. Okay, now it's gonna work. I mean, I'm 60% sure. Today, I'm hoping to exploit the most powerful coding technique there is. We're almost at the end. All the optional challenges completed, except for this. This is a pretty shitty level, but here, 2 more remain. And today, I'm gonna tackle the decimal doubler. The goal here is simple. Starting from 1, take these data cubes, put them on these sensors, press the button, display the number here, and each time multiply the number here by 2. So create a sequence of numbers 1, 2, 4, all the way up to over 8 million. Now, I've already completed this level and I've completed the optional size challenge, meaning my code is less than 25 lines. It's this one. So I've got a few solutions. This one is 24 lines, but it's really slow. This one, on the other hand, is much faster and a bit longer. And the third one, yeah, I don't think this works. What does this do? Calculate 1 divided by 0. 1 divided by 0. Oh, they all die, obviously. So anyway, how does this actually work? Took me a while, but I've realized a simple trick there is to multiplying numbers by 2. What I do at first is that all people take their data cubes and place them on these sensors. This guy then presses the button and displays the number on this display. Then these people start calculating. So first they check the person to their right. I'm actually gonna show this on a larger number so you can see clearly. There. So what these people now do, for example this lady, she calculates the number to her right, which is this 5, times 2, stores it into memory 1, as you can see here. So in memory 1, she should have a 10. Then she calculates her own number, the 2 times 2, which is 4. And now, if memory 2 is more than 9, meaning you yourself are gonna have an overflow. In that case, you would have like 12, and you need to subtract 10 because you're only representing a single digit. And you do the same for the person that was before you. So this 5 times 2 is 10. Is it larger than 9? Yes, it is, meaning we have an overflow. So you should add 1 to your number. Otherwise, here I times it by 1 and here I just add a 0. And that's just so the people are in sync and all of them have to do the same amount of calculating. So now she has 4 in memory 2, and there was an overflow from the previous person, so we add 1, making it a 5. Now they all pick up their data cubes and write the calculated number. Obviously, drop them down, and we've multiplied this number by 2 essentially. If I run the code, you can see that the numbers keep increasing, and eventually we reach the end. 28 commands, we don't really care, but the speed is 7 seconds slower than we want it to. So somehow we need to create a better algorithm and shave off these 7 seconds. Or we're gonna use the coding hack I promised. Obviously, I don't think I'm gonna be able to nail this first try, so I'm gonna copy this code and place it in this tab. Just in case I fuck it up, I still have the backup. Now, the trick is that these calculations take a really long time. So obviously, the best coding trick is just to hard code all the values. I'll be right back. So basically, we've got 10 digits we need to cover by if statements. I wanted to halve the intervals. So say if it's larger than 4, meaning 5, 6 to 9, then do this. Otherwise, it's lower and have 5 more if statements. I sadly can't split this anymore because there's an odd number of these branches. But I think that this game, when it tries, computing the code, it actually only looks at the number of the if statements. And I could just add an additional condition here and say memory 2 is 5, then we want 0. And what else times 2 is a 0? Well, that's a 0. So I think if we do this, that should essentially be just as fast. And that should be an OR, obviously. So eventually we came from this, where we have to calculate memory 2 or your item times 2, and then check if there was an overflow. So 2 calculations every time, to this 5 if statements every time. And we could do the same for these remaining 2 calculations. It shouldn't be such a problem, but for now, let's see if this works. And also what we need to do is synchronize with the button person, because the way he was synchronized was that he just did 5 calculations. And I said we got rid of 2, but we did introduce 5 if statements. Let's just try it and see whether this works. He's probably gonna be a bit slower, right? So they do a bit of calculating, now do the if statements, another bit of calculating, and yeah, they're already calculating, and he pressed the button a little late. Let's see, we might go out of sync. Wow, oh wait. I think I fucked up somewhere because this guy wrote down a 0. That's wrong, obviously, because 1 times 2 is not 0. So let's try again. So you, sir, you should set memory 2 to 0. Oh wait, oh no. Okay, should be good now because I forgot to initialize memory 2 as the item you're standing on. So let's see now. Yeah, that's a 2. And that's still a 2. Okay, what went wrong there? So yeah, you've got a 2 on your data cube. So that's not this branch, not this branch, but this branch instead. So you go and you set memory 1. Shit. Okay, so that's supposed to be memory 2. Let's try again. Oh, look, it's working. These numbers seem a bit weird. I don't think these are the multiples of of 2. Okay, so it went sideways at some point, but the beginning was fine, because we had 8, then a 16, now please be 32, 98. You went from 16 to 98. Oh shit. How did you manage that? So you just did 6 times 2 is 12. That's your neighbor. Now your item is a 1, so you should set it to 2. That's right. Oh, no. I messed up. Okay, so basically what happened, he looked at his data cube under his feet. It was a 1, so he triggered this branch and set it to 2, which then means he triggered this branch, set it to 4, and since it was 4, he also triggered this branch, set it to 8. And since there was an overflow, he added 1. Okay, I'm gonna have to redo this. So basically, let's call the current number you're standing on memory 3 and compare all of these to memory 3. And then you normally update memory 2. Okay, now it's gonna work. I mean, I'm 60% sure. Now it has to work. Come on, let's go faster. 4, 8, 16, and 32. All right. So the numbers seem quite consistent. Now I forgot to keep watch. Does this person keep pressing at the right times? Yes, he actually managed. So wow, let's see, was this faster? It has to be, right? Surely. Come on. Yes! Nice. So basically 80 seconds faster than we needed to, and about 90 seconds faster than the original solution. Now let's just see how far I can actually push this, because we can get rid of this calculation and these calculations as well. So here we multiply the neighbor's cube, so the cube of the previous person, to see if there was an overflow, and then we add 1 or 0 to our own number. Right, let's get rid of that, and we're gonna do a bunch of these if statements again and just compare it to the neighbor's cube. So here we set memory 4 this time to the cube next to you, and I just realized we actually didn't have to multiply it by 2 here. We could have simply said if your neighbor's cube is larger than what causes an overflow, so 5 or more, right? If it's 5 or more, you add 1, otherwise you don't. We didn't have to really calculate this memory 1. So actually we can simply say memory 1 is the cube next to you. If it's larger or equal to 5, set 1, otherwise 0, and then add this overflow to our result. And obviously we need to remove a single calculation from the button person. So let's see if this works. I'm a bit worried this time we might actually be out of sync. But so far, yeah, there we go, that's a 0. Yeah, it doesn't work, he's out of sync. But to fully complete this, I probably want to get rid of this calculation as well. Now, I've got the overflow branch ready, so if the number next to it is larger than 5, you have an overflow. So if you had 0, now you have 1, 1 gives you 2, and so on. And obviously there's an issue. What if the person next to you causes an overflow, and you have a 9. Are you gonna cause a double overflow or something? Luckily not, because 9, your 9, times 2 is 8. The person next to you knows of this overflow, and you're gonna upgrade to 9 at best. If you had a 9, it's gonna be 18, so you can upgrade to 0, we're fine. So if memory 2 is a 9, we can set memory 4 to 0 without any issues. And since here we never want to add any numbers, I just need the if statements to, keep the people in sync. So I'm gonna leave the if statements empty, just because, and always set memory 4, which is our outcome, to be the same as memory 2. So now the button person is for sure gonna be wrong. We're just watching the data cube people. So let's see. 1, 2, 4, 16, yeah. Actually seems legit. So I think they're doing it correctly. Great. Now, how do we sync up with the button person? He's too fast. He's too fast, okay? So let's slow him down, and I don't think adding another calculation is gonna help, because then he's gonna be too slow. So let's take an additional step like we had before. So 2 steps, 1 calculation. 1, 2, 4, 16. Oh, it seems to be working. Please don't mess this up. Yes! They didn't mess it up. So let's see what our final time is. Come on. 58 commands. Nice. 78 seconds. That's brilliant. I mean, look at this code. It's like, I'd say it's not the best I've ever seen, but it might surprise you. Might not actually, but it's not even the worst I've ever seen. But the main point is that it works, and we're never gonna have to read it ever again.